Hey guys, we're going to start notes 10.3, which is surface area of pyramids and cones. This is our second day of surface area, and today we're going to be talking about the surface area of pyramids and cones. The first shape we're going to talk about are pyramids. In this picture right here, we have a pentagonal pyramid because the base is a pentagon, and all of the faces are triangles, and it comes to a point at the top. The first thing we need to talk about is different parts of our pyramid. This dotted line that reaches from the top vertex to the center of our pentagon is just our height. Also known as h. Okay, this other dotted line that goes from the vertex but is slanted and goes to the center of one of our sides, this is called our slant height. And for some odd and strange reason, instead of using an S, they use a cursive L. So lowercase l for slant height. And then obviously from the center to the edge here, that would be your radius. Also known, you can also use this as a Pythagorean theorem because it is a right triangle. Okay. All right, the lateral surface area of a pyramid is lateral area is equal to 1/2 of the perimeter, big P perimeter, times L, the slant height. So surface area is 1/2 big P times L, 1/2 the perimeter times the slant height. The total surface area, remember lateral area is just the distance around the pyramid. So all of the faces areas added together. So for example, here's a square pyramid. This would be a picture of just the lateral area because there are 4 triangular faces. So the lateral area would just be the area of all 4 of those added together. And then the total surface area would not only be those 4 areas of the triangles, but also the base. So the total surface area would be 1/2 P times L, just like lateral area, but then you also have to add the area of the base. So all 4 of the shapes, 1, 2, 3, 4, would be the lateral area, and then plus the area of the base would be the total surface area. Okay, so let's go ahead and use these formulas. But on example 1, first we're going to find the height of the square pyramid. Okay, so far we have the slant height, which is 15. Now we don't know the height, that's what we're looking for here, is our h. And we know one of our side lengths of this square is 18. Okay, well, we actually do know the radius because the radius goes from the center to the center of an edge, and it's also half of what your side length is. So if this is 18, then our radius here has to be 9. Let's go back up and do this one up here. So let's say that this edge right here was 10. That would make our radius 5 because it's half of this edge because it only goes to the center. The edge here would go from one vertex to the other. So that's why the radius is half of an edge. Okay, back to our problem. If our radius is 9, our slant height is 15, we can find the height by Pythagorean theorem because this is a right triangle on the inside. A squared plus b squared equals c squared. Okay, let's say A is our 9. B would have to be our height. We don't know what it is. And C is our hypotenuse, which is 15. So 9 squared is 81, plus h squared equals 15 squared, which is 225. Subtract 81 from both sides. So h squared is 144. So in order to find the h, We have to square root both sides. The square root of h squared is h, and the square root of 144 is 12. So the height of our pyramid here is 12 inches. So that problem, all we needed to use was Pythagorean theorem to solve. Okay, on example number 2, find the lateral area and the surface area of a regular square pyramid. Okay, well, a square pyramid is the same shape as the one from the previous problem. So I'm going to attempt to draw this. It's going to be a little bit tricky with what I'm using here. Okay. Oops, that one's kind of off a little bit. Not doing a very good job. There we go. Okay, that's about as good as a square pyramid as I'm going to get here. So in our square pyramid, it has a base edge of 14. So each one of these guys, since it's a square, each one of them are 14. That one's 14 as well. And the slant height is 25. So slant height is 25. Find the lateral area and the surface area. Okay, well, our formula for lateral area, you always write your formula first. Lateral area is equal to 1/2 times big P times L. Okay, well, the first thing we're going to need to find is big P, which is the perimeter of the base. So, well, the base is a square, and each one of our sides is 14. So 14 plus 14 plus 14 plus 14. Perimeter, not area. Well, 14 plus 14 plus 14 plus 14 is 56. Times the slant height. L stands for your slant height, which is 25. So when we plug this in, 1/2 times 56 times 25. And then we're going to go ahead and go to our calculator and plug this in. Okay, so we're going to plug this into our calculator. I'm going to use 0.5 as 1/2. So 0.5 times 56 times 25. I'll put it all in the calculator at one time, and we get 700. So our lateral surface area of this square pyramid is 700, and it's centimeters squared. Okay. We also need to find the total surface area, which our formula for that is, looking at the top of the page, 1/2 big P times L plus big B. So the only thing that we haven't found so far is the big B, which is area of the base. We know that 1/2 perimeter times slant height is the same thing as our lateral area, which is 700, plus the area of our base. Well, let's come back over here. Remember, our base over here is the square, and area of a square is just side times side. 14 times 14 would give us 196. So the area of our base is 196. And 700 plus 196 is 896 centimeters squared. Okay. Number 3 we will save for class tomorrow. So go ahead and turn it on the back. Okay, now we're not looking at pyramids anymore. We're now looking at cones. Cones also have a similar right triangle inside of them, just like the pyramid. This perpendicular line straight up and down would be your height. Must be perpendicular to the base. Okay, this guy here on the slant is your slant height, still known as a lowercase l. And obviously from the center to the edge of a circle is your radius. So there completes your right triangle. Okay, this is a net of a cone. Here is your base, and here is the lateral surface area of the cone. That's why it's a big L. Okay, lateral surface area, big B, area of the base, little r is your radius, and cursive L right here is your slant height. Okay, the formula for the lateral surface area of a cone, all of these are on your chart, on your formula chart, is pi r L. So pi times the radius times the slant height. And the total surface area of a cone is pi RL, so the lateral area, plus the area of the base, which in this case our base is a circle, and the area of a circle is pi r squared. So pi RL plus pi r squared is the total surface area formula for a cone. Okay, let's go ahead and look at example 5. Find the radius of the base of the right cone. Okay, so in this picture, we're not using lateral area or total surface area because all we're looking for is the radius. We already have the slant height, which is 34, and we already have the actual height, which is 30. So all we need is the radius. So we need the piece from the center to the edge. So again, this is a right triangle, so we're going to be using Pythagorean Theorem. A and B are always, oops, this should be your height. A and B are always, make your L, make your right angle. So R, we don't know what our radius is, so radius squared plus our height is 30 squared equals our slant height, the hypotenuse, 34 squared. Okay, so 30 squared is 900. And 34 squared is 1,156. So to get r squared by itself, we would subtract 900 from both sides. R squared is equal to 256. And since we need r and we have an r squared, we're going to have to take the square root of both sides. So the square root of 256 is 16. So our radius in this problem is just 16 inches. Okay, let's move on and look at number 6. We're finding that the lateral area of this waffle cone here is 45 pi centimeters squared, and its diameter is 6 inches. Find the slant height and the height of his waffle cone, not including the ice cream. Okay, so the first thing that is given to us is our lateral area. And we know that from our formula, lateral area is pi RL. Okay. Another thing that's given to us is the diameter, which is the distance that's all the way across. Okay. So if our diameter is 6, then that would make our radius 3 because it's half of 6. So let's go ahead and plug in what we know. We know the lateral area is 45 pi, according to our problem. We know that pi is pi, and we know the radius is 3. But we need to look for the slant height. So we have to work backwards to get the L by itself. So we need to get rid of the 3 pi. So we're going to divide both sides by 3 pi. The 3 over the 3 cancels. The pi over the pi cancels. And the pi over the pi over here cancels. So we just have that our slant height is equal to whatever 45 divided by 3 is. Well, 45 divided by 3 is 15. So our slant height of this cone is 15. But it also asks us to find the actual height. So we found the slant height, now we need to find the height of the cone. So the height of the cone is this dotted line right here. Whoa, that's ugly. Okay, so we need to find this. So just like in the previous problems, when we have 2 of the lengths of the sides of a right triangle and we need the third, we're going to use Pythagorean Theorem. Our a squared can either be the 3 squared or the h squared. I'm going to use the 3. Our b squared has to be our h what we're looking for. And our c squared is our hypotenuse, which is a slant height, 15 squared. 3 squared is 9, plus h squared is equal to 15 squared, which is 225. Okay, subtract 9 from both sides. H squared is equal to 216. And then we need to take the square root of 216. Okay, I'm going to go ahead and put that on my calculator because that is not a perfect square. The square root of 216 is about 14.7. And it's centimeters. So the height of our cone is about 14.7 centimeters, and the slant height of our cone is 15 centimeters. Okay, we're going to go ahead and save number 7 for class tomorrow, so I will see you guys then.